Linx allows you to build flexible and complete backend applications. In this video, we're going to cover more ways to use Linx. We're going to cover how you can load data from any source and then transfer the data to any target. For example, you may have a database, Excel file, flat files such as CSV or text, XML, JSON, or API, or even a binary file that you need to read data from. With Linx, you can build an application that will read the data, and you can also apply any transformations that you need onto that data. The data can then be sent to any target, again, such as database, Excel file, flat file such as CSV or text, XML, JSON, sent via email, or you can even distribute the data via an API that you configure and that is then hosted and monitored by Linx. Let's look at how a text file can be imported by Linx. To import a text file such as CSV or text, we're going to use the File plugin. In the File plugin, we can use the text file read component. Here we can configure the file path, which indicates what file to read. This can either be set by you, or it can be made completely dynamic. You can also configure the encoding. There's a few options available here. Underneath that, we have the return options. Here you can select complete line by line or list of lines. It all depends on how you want to use the data in the file itself. The fields configuration allows us to set up file format, text qualifier, lines to skip, along with the definition of fields, which can be imported from the file itself. Here we show how these fields can be imported from the file via the header. These are also completely customizable. You can add additional fields as you require them or skip fields. You can also load a test file to see how the fields will look and behave on runtime. When the return option is set to line by line, each line in the file will be looped through. This means that we can apply specific transformations or load that specific line item into a database. I'm going to set it to list of lines so that we can test and view the data. In debug mode, I'm able to see all of the data that is read from the file as a list. Next, we want to read all of this data into a database. To do this, I'm going to set the return options to line by line because I want to loop through every line in the file itself. Then in the database plugin, I'm going to use the execute SQL component. This will allow me to execute a specific SQL script. We need to set a connection string, which I've already created as a setting. Now for my SQL, I'm going to generate a very simple insert script with Linx. Now we need to define our parameters. We can do this by using the fields that are returned from our file via the text file read component. We can also add additional fields by using static data or by using other variables in Linx itself. You can also apply transformations in your SQL script. Now when the application is run, the file will be read and each line item will be returned separately. The line item is then inserted into the database. You can also apply data transformations in Linx itself. There are multiple ways of doing this. For this example, I'm going to use a string to change the product name. We simply need to select the variable that we need to change. In this case, it's going to be the product name. And then in our expression editor, there are multiple expressions that we can apply to that specific variable. For example, I can replace something in the name with something else. The Linx expression editor has multiple functions that are available for you to apply transformations and logic checks on your data. Next, let's take a look at how to load data from an Excel file. To do this, we will be using the Excel read component in the Excel plugin. Here we can set the file path, which can be dynamic or static depending on your requirement. You can also change the read type and then set the range. This will return all records in the range that we specified. We can also loop through records so that we can access each record individually. When going into debug mode, we can have a look at how the data will look in runtime. You can also load data from a specific range in all worksheets. There's a sheet name filter so that you can limit the sheets that are going to be read through. Executing the application in debug mode shows us the data again. We will now read each record in the Excel file and then import that into a database. We're going to use the execute SQL component in the database plugin. I'm again setting my database connection string from a setting that I've created, and I will generate my insert with the help of Linx. Assign the input parameters as the columns that are read from the Excel file. You can also add static data or variables that have been declared in Linx. On execution, Linx will read each record in our specified range and will then insert each of those records into the database. Now let's take a look at loading data from an XML file. To do this, we're going to use the XML plugin, and specifically, we're going to use the XML reader function. Here, we can set the source. This can either be a file or a string. You can also set the XML file. Again, this can be dynamic or static depending on your requirement. You could, for example, use something like the list files component to list all files in a directory and then simply pull the file name from there. Next, you need to set up the schema. This can be done in multiple ways. You can either load the schema directly or build the schema from your existing XML. I'm going to choose to build it from my XML. You can also set up custom property mappings if you need to. If we run the application in debug mode, we'll be able to see what data is returned. Here we can see the structure of how the data is going to be returned. Because we're going to receive a list, we will have to loop through that list. To do this, I'm going to use a for each component. Now simply set our product list as the list that we need to loop through, and then we're going to insert the data into a database. For this, I'm going to use the execute SQL component in the database plugin. You can interact with virtually any database using this plugin. Now we need to set our connection string. I'm going to use a setting that I've created for this. And now inside of our SQL dialog box, we can see the variables coming from the for each loop. These variables we can now use to insert into our database, update records, or whatever you need to do. You can also add additional logic, for example an if-else statement, if you need to skip certain records, or perhaps you need to apply specific data transformations on specific values. Let's take a look at how to read a JSON file. Although JSON isn't typically in file format, you could still read a JSON file in Linx. To do this, we're going to use a combination of the text file read component available in the file plugin, along with the JSON reader component in the JSON plugin. With our text file read component, we're going to read the complete file, and with the JSON reader component, we're going to use the text file read string as our JSON string. You could add a custom property map if you needed to. You need to set the output type in order to make it a little bit more manageable. To do this, I'm going to change it to list and then set it to a custom type that I created called product. This is what product looks like. So now our JSON reader will return a list of products. When running the application in debug mode, we can see what the data will look like in runtime. You can insert this data into a database, host it on an API, put it into a file, whatever you need. But in order to access it, we will have to loop through the list. To do this, I'm going to use a for each component. And then simply select the JSON reader as my list. Then for each data item, we can choose whatever we need to do with it. For example, you can use the execute SQL component in the database plugin to insert this data into a database. Let's look at how data can be imported from a REST API. This can be done by using the call REST endpoint function in the REST plugin. This function allows you to call REST endpoints by specifying the URL, method, query string, and any additional parameters that are needed. Query string parameters can be defined in the query string dialog box. Methods include get, post, put, and all other standard REST methods. Body format can also be set to text, XML, JSON, stream, URL encoded content, or multi-part encoded content. Body format can also be specified. Other settings include sign with certificate, sign request, the output type, which we will leave a string right now, handling all status codes, allowing untrusted certificates, timeouts, as well as setting up a web proxy. You also have full control over authentication methods. Let's call a simple endpoint in debug mode to see what the data output looks like. For now, data is coming through as a JSON string. This JSON string can be imported into a type to make it more manageable. In Linx, types can be imported from XML or JSON objects, as well as schemas. Types can also be created manually without importing them. This is what the type looks like once it's imported. We can now set the output type to be a list of the type that we imported. This will make the data much more manageable. When calling the endpoint in debug mode, we can now see that the data is in a much more manageable format. Because data is in a list, we can use a for each loop to access each individual data element in that list. From here on out, the data can be used in any way, shape, or form. You could, for example, write the data into a text file or apply transformations to it. You can even write the data into a database. Data can also be combined with data from other sources. It will all depend on your requirement. Let's write the data from the API to a database. I'm going to use the connection string that I've already created as a setting. For the SQL, I'm going to generate an insert via Linx. Then, for the parameters, you can access the values in the for each loop. This, of course, is not the only option. Once the data is obtained from the API, it can be used in any way, such as storage, manipulation, distribution, or any combination of the sort. Linx allows for various different database interactions. Here, we will use the database plugin that allows us to do transactions, do database bulk copies, execute any SQL statements, execute store procedures, and interact with MongoDB. Let's use the execute SQL function. To start off, we're going to have to set a connection string. This can be done dynamically or by using the connection editor. You can select SQL Server, Oracle, or ODBC. When using ODBC, you can connect to any database technology, such as MySQL, Postgres, or anything else. You can also create a setting to store your database connection. This makes it a lot easier if you need to refer to it multiple times throughout your solution. Settings can also be configured on your Linx server, meaning that you can set one specifically for dev, prod, UAT, or an environment that you need to connect to. Next, we need to set the SQL script. Here we have multiple options. You can either generate a template from Linx, or you can create your very own custom SQL script to be as complicated or as simple as you need it to be. Once the SQL script has been created, you can also test it to see what the result will be. Here it is important to note that if a SQL script will be able to execute on the server, then it will be able to execute in Linx. Other settings include timeout, result type, as well as return options. Here you can select first row else null, list of rows if you want the complete dataset, or row by row if you want to loop through each row that is returned by the SQL statement. Once you have the data, you can do anything with it. For example, you could pass it into a REST API, or write all of the records to a text file. You could even write the data into another database. This is very handy when you want to do data migrations. You can simply use another execute SQL function, this time with a different connection string. You can apply any transformations you want inside of your SQL statement or by using the expression editor. You can even transfer data from one type of database to another type of database, for example, from SQL Server to MySQL. Directory Watch is a very useful feature in Linx that allows you to execute functionality based on changes in a directory. The service will monitor a specified directory, and upon any changes in that directory, for example a file has been dropped into it, functionality will be executed. The Directory Watch has a few settings that you can configure. These include a filter, which allows you to filter for a specific file type, let's say something like Excel files only, whether or not subdirectory should be included, and the path. The path can be either static or dynamic, depending on what you have available. There are also different watch options. These include watch for changes, watch for creation, watch for deletions, and watch for renaming. These will each get their own event handler, And how they work is, for example, a file is created in the directory, then the created event handler will execute. Functionality must thus be built inside of the event handler to execute. One option is to build the functionality in a function outside of the event handler. For example, let's build a very simple function that will read the data from the file and import it into a database. I'm going to create a parameter that will contain the file path. Then to read the file, I'm going to use the text file read component in the file plugin. Let's set the file path to our parameter and then do all of the normal configuration in order to return the data. Then in order to insert this data into the database, I will use an execute SQL component underneath the data plugin. Here again, we will need to do our normal configuration. Here it is important to note that we could apply transformation to the data if we needed to. These transformations can be either applied inside of our SQL script or outside in a Linx expression. Now that we've created our function, we can add it into our event handler. We will need to assign the parameter for the file path, and then we're ready to test. We can do this by using the debug mode. By debugging the directory watch, we will be able to see what happens on runtime. To test, I'm going to copy a very simple file into the directory that we're watching. And now we can see that the create event function fired. We can also see it execute and then look through the data that is being read by our text file read component and that is now being inserted into the database. Directory watch is extremely useful to orchestrate file imports. Now that we've taken a look at importing data with Linx, we can take a look at exporting data. Linx allows for the creation of highly custom text or CSV files from your data. To do this, we're going to be using the text file write component in the file plugin. This plugin allows us to write text to any type of file, be it CSV, text, or anything in between. In order for us to write data, we will first have to get that data. We're going to be using the execute SQL component in the database plugin to retrieve product records. We need to do all of our normal configurations such as the connection string, as well as create a SQL script. This data will be looped through row by row that we will write to our text file. The text file write component will allow us to create the text file with the data in it. It has a few options. First of all, we need to set the file path. This is where our file will be created and where the data will be written to. This can either be set statically or dynamically depending on your requirement. If you choose to set it dynamically, you can use the expression editor to combine variables, functions, as well as static text to form your file path. Next, we need to set the contents that will be written to the file. Here again, you can set it statically or dynamically depending on your requirement. It's useful to use the expression editor to build a line. For example, we will in this case have multiple columns. These columns need to be combined with a comma separating them in order to build our CSV file. You can dynamically build up your string to be in the format that you need it to be. We can also set encoding, what to do if the file doesn't exist, for example, create the file, or what to do if the file does exist. In our case, we're going to append the data. Now we can simply test our function in debug mode, and we've created our CSV file. Linx allows for the creation of Excel files with data from any source. This is made simple with the Excel plugin. Within the Excel plugin, we are going to use the Excel write function, which will allow us to create Excel files. Before we can write data to an Excel file, we first need to collect it. For this example, let's use the execute SQL function to retrieve data from a database. I've pre-configured a connection string. Next, we will also have to configure the SQL. It is important to note that you can write any data to an Excel file. You don't need to specifically pull it from a SQL database. You could, for example, pull that data from a file, an API, or anywhere else. Now that we've got data to work with, we can write that data to an Excel file by using the Excel write function. There are multiple properties for us to configure, such as the file path, which is the file path of the file that we're going to write the data to. We can also choose what to do if the file does not exist. We can create a file or create a file from a template. We can also specify the sheet name, if there should be footer rows, and the values that we're going to write to the file. It's important to note that the file path can be either static or dynamic, meaning that you can specify what the file path should be in the expression editor. This is especially useful when you need to dynamically configure what the file name will be. For example, you need to create an export for a specific month, or you need to create a report for a specific client. For now, if the file doesn't exist, we're simply going to create the file. Next, we need to set the values. Here we're going to set the columns to our fields that we're pulling from our database. You could also apply transformations to the data in the expression editor if you needed to. And that's it, we're all set to test. We will be creating our Excel file in this folder. To test, we can simply debug and then run our function. Once our function has executed, we'll now be able to see the data that has been written into our Excel file that has been created for us. Let's delete this file because I want to do something else as well. I want to create a file from a template that I've pre-created. To do this, in the File Does Not Exist drop-down, simply select Copy Template. This is what the template looks like that we're going to copy. We also need to set the template file location. This can be static or dynamic, but since we're always going to refer to this template, I'm simply going to select it in my file selector. And that's it, we're ready to test. Now we can debug again, execute the function, and when opening the Excel file, it should be now formatted according to our template. And that's how you can quickly write data to Excel files. You can create those files or even append data. Once the file has been created, you can do anything with the file. For example, you can send it via email by using the email plugin and then use the send email function. You can also copy the file to a specific location, upload it to FTP server, or upload it via API. Linx also supports the creation of JSON files. With the JSON plugin, you can use the JSON writer function in order to pass any data into a JSON object. However, this isn't required. Linx natively handles all data as a JSON object, meaning that we only need to pull data from a data source and then write that data to a file. For our example, we're going to pull data from a database. I'm going to do all of my configuration as normal and then simply generate a very simple select SQL statement. This will return a list of products for us. I'm going to set the return option as list of rows, and then we simply need to write that list of rows directly into a file by using the text file write function in the file plugin. For the file path, I'm going to specify a JSON file for us to write to. As with most file paths in Linx, this can be completely dynamic or static depending on your requirement. For the content, we're simply going to select the list of files retrieved by our execute SQL function. And that's it, we're ready to test. We're going to create the JSON file into this folder. Now all I need to do is debug my solution and run my function. And there we go, our JSON file has been created. As previously stated, we could use the JSON writer function in order to write any data into a JSON object. This is specifically useful when you need to have a finer control over your property map. And that's how you can write data to a JSON file in Linx. You could also write data to an XML file by using the XML plugin. The XML plugin has an XML writer function which will allow you to write any data into an XML format. That XML data can then be written into a text file, similar to what we did with the JSON object. Linx allows for the easy creation of fully customizable and robust APIs. This can be done by using the REST plugin. The REST plugin allows you to call REST endpoints, but it also allows for the creation of REST APIs via two different ways. You can either use the REST host service, which will allow you to import a pre-created OpenAPI 3 specification to create your API, or you can use the simple REST host service, which will allow you to create your API by using a wizard. To start, let's take a look at the simple REST host. The simple REST host has a number of properties for you to set. Among these are the base URI. This is the URI where your API will be hosted. For security, you have two options to choose from, API key or HTTP bearer. Operations are essentially endpoints. Here, you can specify the endpoints of your API. You can add as many operations as you need. Each operation will need a name as well as a path. You can select the method of your operation, and there are multiple to choose from, such as get, put, post, delete, and many more. You can also set header parameters as well as query string parameters. Multiple parameters can be set here. You also have full control over the request body as well as the response body. As an example, you could return a list of JSON objects if you needed to. For example, I'm setting my response body to be a list of products. You can also choose whether or not the security scheme should be applied on this specific operation. Once you save your operations, you'll notice that they have been created as event handlers underneath your simple REST host service. This is where you will build your functionality. There are also many other properties to set, such as the maximum connections, maximum request size, API documentation, of which there are two. You can either choose to have your API documented in Redocly or via Swagger UI. You can also show additional events such as the authenticate event, before operation or after operation, which is useful in certain cases. Now that our getProducts operation has been created, it's time for us to populate the functionality that will execute inside of this operation. For this operation, we're going to retrieve all products in a database. To do this, I'm going to create a new function. This function we're going to call getProducts, and we're going to return a list of products. This is what the product type that we're going to return looks like. Inside of getProducts, I'm going to create a list that's going to be a list of products. We're then going to use the execute SQL component to connect to a database and pull all of the products inside of this database table. I'll be using Linx to generate my select query. Next, we simply need to add each product into the product list. To do this, I'm going to use an add to list component, and then I'm going to simply map my fields. Now that we've created a list of products, we can simply return that list as the result of this specific function. We can now simply call this function in our getProducts operation. Because the result of our function is what we require in our response body, we can simply return the result of that function as the result body. And that's it, we've created our API with our getProducts endpoint. Now we can debug it to see how it will run. Debugging the simple REST host will create a locally hosted version of the API that we can test on our local. We can see here that the Swagger documentation is available for us to use. I'm going to use it so that we can test our API. When executing the endpoint, we see our data as a result. The simple REST host is a fantastic option when you need to quickly create an API to host data, but it's not the only option in Linx. In Linx, you can also use the REST host, where you have much more control over your API. Here, you'll see similar properties with one exception, the API definition. You need to specify your API via OpenAPI 3 specification. Upon saving, your endpoints will be created as operations again. We need to configure all of the properties as with the simple REST host. What is important to note is because you now have access to the API definition, you have much more control over how the API will behave. We need to add a functionality in our operation again. I'm going to use the same function that we created to return the list of products. I'm also going to return in the response to 100 the list of products that we generate in that function. And now we're ready to test our API again. We can debug the REST host to create a locally hosted version of our API. I can open the Swagger documentation and test the API once more. I chose to host the Swagger documentation again to make testing simpler. Once we're ready, we can deploy our solution to a Linx server by using the deploy button. Once deployed, the API will be hosted on a Linx server, meaning you don't have to worry about hosting. And that's how you can easily create REST APIs using Linx. Once you've created a file, you may want to send it via email. In Linx, this can be done by using the email plugin. The email plugin allows us to read emails and send emails. For this example, we're going to send an email by using the send email function. This function will allow us to send emails to a SMTP server for distribution to recipients. Here we've got multiple properties to set, which mostly can be set dynamically. We can set the subject, we can set the body in two ways, either by doing simply a text body or an HTML body. Text body is very simple and straightforward, whereas your HTML body can be a lot more customizable. Both the text and HTML bodies can be defined dynamically. Next, we need to define our attachments. Attachments are defined in a list. This means that you can have as many attachments as you need, depending on your SMTP server limitations. We're going to attach this product export CSV file. These attachments can also be defined dynamically, so you don't have to necessarily know what the attachment file is beforehand. Next, we need to define some credentials such as the username, password, SMTP host, SMTP port, and so forth. I've created a setting for each one of these properties. Settings are essentially global variables that you can use throughout your application, and you can set them and customize them on your server. Let's set each property to its corresponding setting. You can set a priority and a timeout, and then also the two CC and BCC recipients. These can also be a longer list of recipients by simply separating them with a semicolon. We also need to set the from, SMTP server, whether or not SSL should be enabled, as well as the port. Once all of these properties have been configured, we are now ready to test. To do this, simply debug the application by going into debug mode and then run the application. We'll be sending the email to this email account. When I debug this application and run the function, the email will be sent. And there we go, the email has been received by my email account with the attachment. This function becomes extremely useful when you need to distribute a file that you've just created. For example, you just created an Excel file that's a report that needs to be sent out to users. As soon as it's created, you need to email it to those users. It's also important to note that files do not have to be created with links in order to be sent via email. You can send any file as an attachment. We have now covered the basics of loading and storing data with Linx. There are a lot more options available, and you can build much more complex and nuanced processes depending on your requirement. To learn more, go to linx.software.